Okay, Miss Sarah. Let's go over this one more time. Lesson 64. Um, so you have two parts to this problem. The first part is the problem itself, the inequality. X is not less than or equal to -2. So we figure that part out first. Well, you have less than, greater than, or equal to. Those are your only options when you're talking about two numbers. They can only be three things to each other. Either a number is less than the other, it's greater than the other, or it's equal to the other. So if you'll write all three of your symbols down and then look at what's in the middle when it's negated, right? When you have that line through it, it's telling us what it's not. We don't care what it's not, we care what it is. So we're going to cross out what it's not. It's not less than, it's not equal to, so it has to be greater. So now we can write what it is. That's greater than -2. That tells us what to graph. Telling us what not to graph doesn't help us. We have to figure out what it is. So now we know. We know that it is greater than because it's not less than or equal to. Now we can graph it. So we draw a little number line. Actually, I'm just going to graph it over here in the pod instead of trying to worry about graphing it over here. But before we can graph it, we have to take into account our domain. And our domain equals positive integers. All right, that's what this says. The domain equals positive integers. So because it's integers, it can only be those little numbers on the line, right? On the little tick marks. Integers are these numbers here. What's in between these numbers are considered rational numbers. They would be included if we say reals, then those are included. But we have a list under reals. We have rational numbers. Reals also includes irrational, right? But under the rational side, we have rational, then we have integers. All right, rational means the line. Integers means the dot. Everything below integers, which would be whole numbers and natural numbers, those include the dot as well. Reals is the line, rational is the line, integers, whole numbers, and natural numbers are the dots. That's how you know the difference. This includes everything. This includes a little less than everything because it doesn't include the irrational stuff. Integers just includes integers. Now this is positive and negative. This is 0 and positive. This is just positive. Okay? So that's how it kind of breaks down. Because this says positive integers, we know it's just the natural numbers. We can't do the negative numbers. So what we want to do is look at what we have over here. X is greater than -2. All right, well, here's -2. So X is not -2, but it's greater than -2. And we know that on the number line that everything to the right is greater than everything to the left. So -1 is greater than -2, but it's not a positive integer. It's a negative integer. And 0 is neither positive nor negative. It's a neutral number, so we can't include it either. So we have to start at 1 and put a dot and 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 a dot, because this is everything that is greater than -2 that is positive integer. Okay? That's how we do this. Let's look at the next one. Let me clear this page off. Actually, I think I'm just going to erase this bit and keep this up for reference. So this says X is not less than or equal to 4. And, all right, here's our symbols: less than, greater than, equal to. It's not less than, it's not equal to, so it has to be greater than. So X is greater than 4. All right, so what is the domain? The domain tells us which ones to graph in that fall into this true statement, right? That make this true. So reals, what is reals? Reals is all the numbers, so reals is the line. So what that means is we go to the 4 and we circle it. X is greater, so it's going to the right. And because there's no equal sign, we have to leave that circle open because it doesn't include 4. It goes right up to 4, but it doesn't include 4. Because 4.1 is greater than 4. So we circle the 4 to show where that stops, but then we go to the right. And that's how we graph that. Because reals, which is our domain, is the line. It includes the numbers in between the integers. So we have to show that. All right, let's look at the next one. Let me erase this part right here. All right, this says x minus 5 is not less than 0. So first, let's get rid of this negated part. It's not less than, so it is greater than or equal to. So x minus 5 is greater than or equal to 0. But now we need to have x by itself, so we have to solve it. So we do it just like we do an equation. We add 5 to both sides so we can get x by itself. This cancels. X is greater than or equal to 5. Now we know what to graph. We know the area of the graph we're looking at. Now we need to know what to graph. Well, this says integers, so that just means dots on the positive and the negative. So x is greater than or equal to 5. That means we can start on the 5 because it's equal to 5, but it's also greater than 5, just the integers. And that's how we would graph that one. All right, so the last one, erase everything here. X plus 2 is less than 5. There's nothing negated here. It tells us what it is, so we don't have to do that whole figuring it out part. We're straight up with what we know. So now we just have to solve this. So we subtract 2 from both sides. We treat this just like an equal sign, right? That cancels. X is less than 3. And what is the domain? The domain is integers. Integers means dots, positive or negative, dots, right? So x is less than 3. So it doesn't include 3. It's less than 3 for the integers. So the next integer that's less than 3 is 2. So we just dot every integer that is less than 3. That's it. That's all there is, and we're done. All right, sweetheart, go back, redo lesson 64. This is not hard. It's just a different way of looking at numbers. Write this down in your notebook cover so that you can see it. So when it says reals, you know it's the line. When it says rational, you know it should be an AL. When it says rational, you know it's a line. When it says integers, you know it's positive and minus, or positive and negative, whole numbers, and it's just the dot on the number. Whole numbers, 0 plus the positive is the dot. Natural is just the positive. When they say natural, they could also say positive integers. That also means natural, okay? Sometimes it's going to say negative integers, so then you just do the negative integers. But you have to look at what this is in order to know how to graph it. All right, sweetheart, have a good week, rest of the weekend, and I'll see you Thursday, and happy Valentine's Day.